Nope. Okay, so what I want to talk to you about, there are a couple things. The first thing I want to talk about is one of the applications of optimization, a specific case that we kind of skipped. I think we should go over. It's called inventory cost.
Yeah, the cost of keeping something in inventory,
Yeah.
not selling it.
So basically, pretend you're a business owner, you're selling a product, so you're storing all these products and you're selling these products, and ever so now and then you have to keep track of your inventory, you need to order new products to keep selling, right? So the goal here is to minimize the cost of storing and ordering products. Of course, without breaking service. Right? So that's sort of the goal that we want to look for here.
When you say without breaking service, do you mean like without like running out of the product?
Yeah, you don't want to have a period where you don't have anything to sell. That would, that'd be a period where you're not making money, right? But obviously, storing a product costs money. You have to rent space and all that stuff. You probably have to hire security guards to watch it and all that kind of things. And of course, ordering products, you would have to pay money as well. You have to have delivery charges, administrative costs, all that sort of things, right? So both of these things actually cost money, and you want to minimize your costs so you can make the most profit, right? So there's a kind of scenario you want to set yourself up with knowing how many things you want to order and how often you want to order over the year, so that you constantly have a steady stream of products, but you're making the minimum amount of orders and you're paying the minimum amount you need to store these items, right? So you do make some assumptions, of course. Right, so here we're going to have some assumptions, which, depending on your business, you could tweak these assumptions. But for now, to keep things simple, we're going to assume that we sell products steadily throughout the year. Which may or may not be the case. Maybe some months are faster and slower and you do this on a month-by-month basis, but we're going to look at this from an annual basis, and we're assuming that we're selling roughly the same amount of products throughout the year. And so this gives us one idea. If we're looking at the amount of items stored, and what would such a thing look like? As time is going on, and let's say X is the number of items that we can store, right? So I have a storage place that can hold X items at any given time. So what's going to happen as time is going on, the number of items I have is decreasing because I'm selling them off, right? So eventually that's going to hit 0, and I'm going to want to reorder X items, right? And then that's going to start selling off. And then when I get to 0, I want to reorder X items, and that's going to start to selling off. And I want these to be seamless, right? I don't want to run out of items and by the next time I order, there's this whole gap where I'm not making money. So as my products are running out, I can only store X of them, so I can't get more than X. So I only have a space to store X, but as they're running out, I want to be able to order just in time so that there's no break-in service, right? And of course, you can order more often or less often, but the idea is, what is the best time to do these orders? Now on average, you will have stored half these items, right? Half the time you have more than this level, half the time you have less than this level. So you kind of look at the simple case, assume you're selling things steadily throughout the year, and you're looking at the average. X over 2 is the average amount of items you're storing at any given time. Now this leads to the equation that you can kind of set up. So this means a good approximation for cost under these assumptions would be something like the following. It's going to be the cost per order to order a new batch of items times the number of orders per year. Plus, now you're going to talk about the cost to store items. Usually it's per item. Times the average number of items stored per year. Right? So I'm going to figure out how much does it cost me to make orders, how much does it cost me to store these items, right? And I sort of make these assumptions that simplify the case, which you can tweak these depending on your situation, but this is the simplest case we're dealing with, right? Basically what this boils down to is, of course, the cost per item is something that you would know or be given, or you'd be able to look at your books and tell, so that's just going to be a constant, right? So it costs me this much to every time I place an order, you kind of know what that is. The number of orders per year, right, if assuming X items are ordered each time. So the number of items per year, how many number of orders would you make? How could you describe that as a function?
Number of orders making a year. Total amount of orders divided by 365.
No, that's if you're making an order per day.
X times whatever amount of time you do in a year.
No. Let's say I sell 100 items over a year and I order 5 items at a time. How many orders would I have made?
20.
How'd you get that?
100 divided by 5.
Okay, so give me a general formula.
Okay, so total number of items
Total number of items, yeah,
divided by amount of orders per year.
which is X, right? By the number of items you order. Okay, so you have that function. Now here, there's the cost to store the item per item.
That's a
Again,
constant.
that's going to be a constant. And what is the average number of items stored? Well, I just sort of illustrated to you, that would be X over 2. So this guy here gives you what's called the inventory cost. And in Tool 5, you will always make these assumptions, so this will always be the form of the equation. It will always have the above equation. What do we want to do with C of X?
Minimize it.
Minimize. i.e. C of X is the objective equation in our optimization problem. So basically, if you have an inventory cost problem, then this equation brings you right to step 5. So let's do an example of what such a problem might look like. See what numbers. we're back to hot dogs again. Super hot dog. Per year. And let's assume at a steady rate. How much does it cost me? It costs $2 per hot dog to store the hot dogs. And it costs me $10 every time I order a new batch of hot dogs. To store them. $10 every time he orders a new batch. So here's the question. How many orders should Jhevon place per year? And how many hot dogs should be in each order? So that's what an inventory cost problem is going to look like.
So you're asking us to solve for X and Y.
Well, yes. I'm asking, in fact, to solve for two things. I'm asking to solve for this thing, right? That's how many orders he should make per year. And X itself is the number of items in each order. So basically, you can minimize this and find the X value that minimizes it. And then that would be the number per order. And then if you take the total he sells per year, divide by that number, that's the number of orders. So at this point, what this equation would look like is, you guys tell me, C of X would look like what here?
Cost per order.
10.
10 times
We don't know yet.
total number of items. What's the total number I'm selling per year?
1,500.
Yeah, so you put 1,500 over X plus
2
2
times X over 2.
times X over 2.
The 2's cancel.
That's my function. So the 2's will cancel. And so the goal now is to minimize this. Which I'm not going to go through. That's just step 5 in the optimization handout. At this point, you guys should be able to do that. So you find the derivative, set equal to 0 undefined, find the absolute max or min. But the nice thing about these is that it's basically always going to be this format of the formula. So you can immediately jump to step 5 if you memorize that formula. So I wasn't sure if I was going to talk about this. It's usually taught in 205, but I've never seen it on a final, so I don't know why they always teach it. And I wasn't sure if I was going to put it on a final. If I do, it will be in the section where you can skip it.
In the bonus?
But also, conversely, if I do, technically it's one of the easier problems. It's easier than your average optimization problem because you don't have to come up with these functions, you don't have to draw a picture, you don't have to do anything. That's always going to be the formula. So you just memorize that, you plug the numbers in, and then you do your calculus. So in that sense, it'll be nice if I decide to put it, but I haven't written the final yet, so I don't know exactly what it's going to be. But I figure it's nice to tell you guys about it anyway. Let's talk a little bit about the final. As I said, I haven't written it yet, so I don't exactly know what it's going to look like. But it should be very close to the fall 2009 format. Right, so...
That was when I started college.
What?
That was when I first started college. That's a long time ago.
Oh, that was just before I graduated. So you must do 9 problems total. two sections. Five compulsory and four from an optional section. Right, so here, in the fall 2009 file, there were four compulsory, but I will limit definition of derivative is compulsory. So I'll throw that in the compulsory. That'll make 5 guys in the compulsory section, and then I'll give you a bunch of problems to choose 4 of them, right? Which that's where your like optimization and your curve sketching and all that stuff is gonna happen. So in these guys, it's going to be like finding derivatives, finding integrals, simplifying expressions, maybe with logs and e's in them, exponential growth or decay problem, limit definition of a derivative.
Like you mean write out the actual definition, or here's a function.
No,
find
here's
the
a function,
derivative.
find the derivative using
that.
Find the tangent line, blah, blah, blah. So basically test one.
Can you
Test
say
2.
that list one more time? All the things you said on the.
Oh, pretty much look at fall 2009 and add limit definition in the top part.
That's found on the math web.
Yeah, the same place where you're getting it from.
So question about the mock file.
So here, so let's do compulsory. So here's what I know I'm going to ask you. Find derivatives. Find find integrals. Simplify expressions. And the definition of derivative. With tangent line. So from the optional section, what you need to know for that optimization, of course, optimization, curve sketching, lane breaks, maybe a limits problem.
Like find the limit as x approaches
Yeah,
blah,
whatever.
function.
Yeah, the speed, velocity, acceleration problem.
Oh,
Am I throwing an inventory cost? Maybe you find in the mood.
Do it.
No.
You spent 10 minutes.
You don't need any more than 10 minutes. Well, the optional section, they're usually all word problems. They're not really. Oh, curve sketching, the ones with asymptotes. So make sure you practice the ones from like the handout. I don't think many of those are on the final. So make sure you know how to find vertical and horizontal asymptotes.
When do we get the last exam?
Come in?
The last exam?
That's the
Probably Monday, I guess. You guys are coming for a mock final on Monday, right?
Are we going over it?
specific time when it's only coming?
What?
Is there a specific time when it's only coming?
Well, I'll talk about that after. Let me try to finish talking about this. Yeah, so it's gonna be roughly.
So anything that's not on this list, I'm not going to study. Is that okay?
Throw
We
one of
already
those.
have that in compulsory.
Yeah, but I might do both of them. Like fall 2009 actually did the same thing. So here they ask you a decay problem, and then in the optional section they put a growth problem. So I might do just swap the two. Yeah, something like that. I'll stick with that format. So it's 2 hours 15 minutes long. So we can start early and finish the usual time, or we can just start at 6 and get out at 8:15. I don't know if that's a problem. You want to start earlier? 5:30 or 5:45?
I'd rather not.
No.
Start at
six.
6. I'll stay until like 15 hours.
Yeah.
Same.
So start at 6. Because I know some of you guys work, so I just want to make sure. But it's a 2 hour 15 minutes long test. So that's that. Anything else I want to tell you?
It's still gonna be in this classroom, right?
Yeah, same classroom.
Okay.
That's I think that's it so far. Yes, I'll stick with this format and I'll. Okay, so yeah, Monday officially we don't have class, so I'm willing to meet earlier or later. So yeah, I'm thinking about a mock final on Monday.
Can we review it after we take it?
Well, it's probably gonna take a lot of time. I'll probably just give you guys the solutions and you read it on your own.
But will the solutions be like step-by-step type of things, or
Yeah,
just
that's
the
problem.
answers?
Like,
Yeah.
seeing the answer is okay, but then actual work up until the answer, where you went wrong,
Yeah.
is a whole different situation.
My solutions are always step by step for the test.
Maybe they don't check it, that's what they tell me.
Yeah, so that's what I'm saying. Like if you guys saw my solutions on the website, I don't just write the answers. I actually do, I work it out.
Nobody checked. The mock final, will you make it similar to the final?
Yeah, yeah. I'm gonna do something like this and probably change the numbers or change the
Like
function.
same difficulty too, right?
Yeah.
So we, so like, is there
Or
something
you-
you want us all to come?
Well, I'm still in the tutoring center 12 to 5, so after 5. I don't care. If you guys want to show up at 6 as usual, you can do that.
Yeah.
So, plan for this weekend. Go over. No. I want to probably make an ordered list because I realized that you actually. So 1. This is an ordered list. This is how you're going to want to practice. Do complete finals under time conditions. At least start with 1. Two. Alright? So that's what you're gonna do. So I know people who like to study, they start by going over all the homework and then go over all the quizzes. Not very efficient. Start with the finals. Do it under time and conditions. Make sure you're fast enough, you're not running out of time, all that stuff. You're putting yourself under pressure so you know the kind of mistakes you're always gonna make. Assess where you are. right? So you go over a final and you realize, you know what, I didn't know what to do with that related rates problem. Now you know there's something to focus on. You need to make sure you fix related rates, right? Well, if you start with the homework from the beginning of the semester, it might be a while before you get to the related rates and realize you have a problem with it. You want to know what your problems are very early on so you can start to fix them, right? And the best way to do that is to go through a whole final where you're going through the motions and you have to switch from topic to topic, right? You have to practice that mental flexibility that you're going to be practicing. So you assess where you are, then go over targeted review problems. Right? So once you figure out where your problem is, for example, related rates, what you're going to do is you're going to go over the reviews, all my tests, all my quizzes, all the reviews that are on the website, and you're going to go and do all the related rates problems until you're comfortable with it. Right? And whatever topics you are, you only focus on that. Don't waste your time with anything. Right? If you get through and you realize that, oh, limit definition by derivatives, I actually got that pretty easy. I wasn't confused at all. Everything worked out fine. I wouldn't practice any more of those. Right? So assess where you are, the things you got stuck on, the things that confuse you, and go through the reviews and do those. And do a very targeted review. 3, repeat. Step 1. And 2. Right? So you never know if sometimes the finals are different, so maybe your related rates problem didn't give you trouble on this final, but on another final the related rates problem gave you trouble. And you're going to want to see why did I have trouble here but I didn't have trouble here. Right? So that's what you're going to want to do. And you're going to keep repeating that kind of process. So you don't want to go over everything, right? You want to really, you don't have a lot of time, so you really want to focus on things. So really start on the final. Try to sit down and do one complete final. You want to really get into the groove of what it is to sit down for 2 hours, 15 minutes and go over everything from the beginning of the semester. Right? And you'll see what you've forgotten and all that stuff. So, of course, 4 math questions. So the tutoring center is open right until the final day. So, tutoring center. You email me. So if you email me, I usually won't give you a detailed solution to the question you're asking, but I can at least point you in the right direction. Oh, think of this, or this is like this problem that I did in class, or something like that.
Will it be open on Wednesday?
Yeah, it's open on Wednesday. So it's open right up until the final day. So our final is on Wednesday. Did I mention that? I did at some point. I think it's in the syllabus, right?
Yeah,
As well. So it's Wednesday the 27th.
Mm-hmm.
At 6 p.m. Expect to be here 2 hours and 15, or faster if you can finish.
Wait, that's when the final is?
Yes.
Wednesday?
At this time.
Oh my God.
So I'll be giving mock final Monday with solutions.
Until for Tuesday.
Tuesday you review whatever you realize that you messed up on the mock final.
Wait, oh. See what's up.
So I guess that's sort of it. You get 100 on the final, you get bragging rights, and you get a prize from the math department, and they're like, "Oh, you're so smart."
Is that true?
There's like a whole party.
Is that true? I've seen we get medals.
Huh?
Yeah, I know.